So we're going to talk about the receptive field in convolutional neural network. So every layer, every layer, um, like this, every layer produces the feature maps or new feature maps from the original image, like this. It filter out the like it filter detect a specific pattern such as edges, corners, textures, shapes. The result of applying that filter is called feature map or activation map. And as the layer goes deeper, the feature map shrinks for the reason of um, to reduce the memory and computation costs, of course, to reduce the memory and computation costs. That's why as the layers go deeper, the feature map is shrinking, so to reduce memory and computation costs. So the receptive fields on the other hand is this one. So what is receptive field? This one is a receptive field. The receptive field is the region of the original image. Is the region of the original image that a neuron can see in the feature map. Let's say this is a neuron in the feature map. Neuron or pixel value. And the receptive field see this one neuron as this one. Okay? So even though we shrink the feature map, right? Even though we shrink the feature map, it doesn't matter. Why? So because its neuron there hold those contents or contexts. Okay? So because a neuron in a deep layer is no longer representing a single tiny pixel region, as we can see here. It is not a tiny pixel. It contains or we could see it as a receptive field. So even though we the feature map size gets smaller, there is no problem because each feature map neuron represents information from many original image pixels. So this is one of the main goals of the convolutional neural networks, to reduce the spatial size, so we have the less computation. So we're talking about the spatial size of the process or the shrinking of the size of the feature maps as output of every layer, like that. As you can see, from the very first beginning, the original image is like 11 by 11, and as the layers goes by, it produces the new feature map of like 9 by 9 and the other, and as the layer goes deeper, it reduces and reduces to this point. As we can see in the actual image, it looks like we couldn't understand what is this. Like for example, from the original image, this is a cat, and after the training or after in the during the training convolutional neural network, we can see it is as a blurred one, and we're gonna recognize the one. But the receptive field could understand what the neuron or each neuron represents. Like for this one, as you can see, this looks like an ordinary pixel, but a receptive field see it as the part or edge or the ear of a cat, and the other side of it, we could see it as the mouth, even though it's a pixel. That's one of the power of the receptive field. Okay, so Like for example, larger objects require larger receptive fields. Suppose we are trying to detect a cat. A cat's ear might occupy 20 by 20 pixels. A cat's face might occupy 80 by 80 pixels, like that. So, therefore, deeper neurons needs larger receptive fields, because if we don't shrink the image or the value of the feature maps, it could still have a 3.2 million values, if CNN skips every feature maps at those kind of large values forever, memory and computation would explode. That's why receptive field and shrinking of feature map is so very important. Okay, so to summarize, the receptive field is the one who sees the neuron as uh, the summary of the receptive field that might represent the particular features of the image. So I hope we understand the topic for today.